Vectors can be multiplied by two different ways. First one is a scalar product. It is also called as a dot product. We have already seen that vectors, as they are having magnitude and direction, they cannot be multiplied by using regular mathematical operations. Suppose there are two vectors, vector A and this is vector B, and if these vectors are making an angle theta with each other, then a scalar product of these two vectors is defined as vector A dot vector B is equal to AB cos theta. If the two vectors are having angle theta with each other, then their dot product or a scalar product is defined as product of their magnitudes and cosine of the angle between them. I will write it here. Product of their magnitudes and cosine of the angle between them. The scalar product has a lot of applications in physics. There are many vector quantities whose product is a scalar quantity. Scalar product, you can see that this quantity is a scalar quantity. So this is just magnitude, this is magnitude, this will be also some numerical. So the total answer will be the scalar quantity. That's why it is called as a scalar product. In physics, we need this scalar product in many places. Like suppose if I have work is equal to, we know that this formula, work is equal to force into displacement. Now this force is a vector quantity and this displacement is also a vector quantity, but their product work is a scalar quantity. Okay, so therefore in physics there are applications of the scalar product. For example, I have taken some block and if I apply some force on it, so there will be some displacement. If I apply some force, so this will be displacement from this point A to point this B. Okay, suppose if this force is not in the same direction, if I apply the force in this direction and there is a displacement on this side. Now if this force and displacement are making some angle with each other, then the work done is given by force into displacement. So force is a vector quantity, displacement is a vector quantity, but their product is a scalar quantity. Okay, and that's why it is given by W is equal to F dot S, which is Fs cos theta. Their magnitude will be Fs cos theta. Let us take one more example of the power. Power is nothing but the work upon time. I can also write it F dot S. We know that work is nothing but F dot S upon time. I can also write it F dot S upon T, which is nothing but the S upon T, displacement per unit time, is nothing but the velocity. So such we can see that power is a scalar quantity, force is a vector quantity, and velocity is also a vector quantity. In physics there are many terms which are scalar quantities and which are a product of two vectors. Therefore, we have defined this scalar product. Scalar product is commutative. Commutative means if this A dot B is equal to vector B dot A. We can prove this. We know that A dot B will be, so this AB cos theta, and this B dot A will be vector B into vector A into cos theta. So this will be vector A into vector B cos theta, and this will be vector B into vector A into cos theta. So this will be nothing but the AB cos theta, and this will be BA cos theta, and both have the same meaning. Therefore, we can write that A dot B is equal to B dot A, and we can say that the scalar product is a commutative. The scalar product is also distributive. Suppose if there are two vectors, so this is vector A dot vector B plus vector C, then that is equal to vector A dot vector B plus vector A dot vector C. So this is called as the scalar product is distributive. Now if there are two vectors which are parallel to each other, for two parallel vectors, so the angle between them will be 0. We know that cos 0 is equal to 1. So for the parallel vectors, so this A dot B will be equal to A into B. So magnitude of product of the vectors. For two perpendicular vectors, so this theta is equal to 90 degree, and we know that, so this cos 90 is equal to 0. Therefore, A dot B is equal to 0 for the two perpendicular vectors. Suppose we are having a three-dimensional Cartesian coordinate system with x, y and z axis. Then, so this vector I is a unit vector along the x axis. This vector j is a unit vector along the y axis, and this k is a unit vector along the z direction. So we can write that I, j and k are the conventional unit vectors along x, y and z directions respectively. Now we know that if the angle between the two vectors is 90 degree, then their dot product will be equal to 0. We know that the angle between the vector I and vector j is 90 degree. Vector j and vector k is also 90 degree, and vector k and vector I is also 90 degree. So this will be equal to 0. Now what will be the scalar product of a unit vector with itself? So this is called as this rule is stated as scalar product of two mutually perpendicular vectors is 0. Now if the theta is 0. So we know that, so this A dot B is nothing but the product of the magnitude of the two vectors. If I take I dot I, J dot J and K dot K, we can write that. So it will be equal to 1 multiplied by 1, which is nothing but the 1. So from this we can say that the scalar product of the two mutually perpendicular unit vectors is 0, and scalar product of the two mutually perpendicular unit vectors with itself is equal to 1. Now suppose if I have any vector A, so this any vector A in a three-dimensional Cartesian coordinate system can be given as AXI plus AYJ plus AZK, where I, J, K and the unit vectors along X, Y and Z directions, and AX, AY and AZ are the magnitudes along the X-axis, Y-axis and Z-axis. Therefore, any vector can be resolved into its perpendicular components as AXI, AYJ plus AZK. Now if I have another vector B as a BXI plus BYJ plus BZK, then if I take a scalar product, I can write plus AZK dot BXI BYJ plus BZK. We can multiply by each term to the bracket AXI dot BXI plus BYJ plus BZK plus AYJ plus multiply by this term don't try to forget this BXI plus BYJ plus BZK. Everywhere unit vector is there. So if I multiply by this AXI to each and every term inside this, so what I am going to get is, we know that vector I dot vector J will be 0, vector I dot vector K will be 0. So the only terms with vector I dot I, vector J dot J and vector K dot K will remain, because vector K dot K is nothing but 1. So I can write here AX BX I dot I plus AY BY plus AY BY J dot J plus AZ BZ K dot K. So which will be equal to AX BX plus AY BY plus AZ BZ. So this will be vector A dot vector B.